All right. Please do not throw the scissors across the room. Cut your neighbor's hair off. All the things that get... Cut your own hair. Both of my kids have cut their own hair whenever they were little. And they always cut it right off. Yeah. Is there anyone in here who did not cut their own hair when they were a little kid? Only Kendall. You cut your sisters? Yeah. Both of my kids just took it. My nephew right now has got a big gap right here where he just... Yeah. Yeah. Boys, at least, though, theirs isn't very long, so it doesn't take very long for it to grow back out. If a girl does this right here, they got a long time till it goes back out. And I
never had black hair girl to be able to cut it.
Yeah. Yeah. All right. So, piecewise functions. We're given a piecewise function here. You got all of your equations and then the condition that you use it for. So to evaluate, you just have to pick the piece that you are going to use and plug in the number. So it's as simple as plugging in the number. So like for example, -2 falls below 0, so x is less than or equal to 0 right here. So you're going to choose that top function. And you plug it into that one only. So 2 times -2 minus 1 is going to give you -4 minus 1. So -5 is your value for that. Now the ones that we really like to ask you about are the ones where you got to think a little bit harder, like f of 0. Because 0 is the place where we cut off the first function and start the second function. So you've got to decide which one to use here. And this is for when x is less than or equal to 0. And this one has 0 less than x. So this does not include 0 right here. This one does. So because we have the or equal to sign with that top function, that's the one we're going to use. So we just plug in 2 times 0 minus 1, which is 0 minus 1, which gives us -1. Okay, something similar is going to happen with number 3. We got f of 5. So for that one, Sophie, which function should I choose? The top, the middle, or the bottom for 5? Middle, right? Because we got the or equal to with the 5 right here. So we will do 5 plus 1 squared over 3, which is going to give us 6 squared over 3. So 36 over 3 will give us 12. Now, number 4 seems to be pretty straightforward because they give you 7, which clearly falls in that bottom category where x is greater than 5. But I find a lot of students miss this one because it seems tricky. Where do we plug that 7 in for this one? We don't. It's just -4 because there is no x to plug it into. So if it's just a constant, it wouldn't matter if we were doing f of 7, f of 10, f of 1,000, f of any number where x is greater than 5, we would get -4 for that answer. Okay. For number 5, f of 1 is going to fall between 0 and 5, so we choose the middle one. We get 1 plus 1 squared over 3, which is 2 squared over 3, which is 4/3, and we'll just leave it like that since those won't divide. And 3 also falls in that middle category, so we would have 3 plus 1 squared over 3 equals 4 squared over 3, so 16 over 3 for that. Okay. Questions on evaluating? Okay. So I'm going to teach this like I would teach if you had never seen piecewise functions before. So this may seem a little bit redundant to you, and I think I also need to change something right here. This first equation, let's make that -4 a +4 every time I mean to change that, and I never do on these notes. If you have never quite got piecewise functions right, maybe this will help you. If you already understand it, it'll just further solidify what you know about it. So what I want you to do is I want you to graph these three. Graph these three separately on your 3 sticky notes that you've got. So you want to graph these three. The first one is a line, so just y equals mx plus b. The second one is the absolute value. What does absolute value look like? It's your v. This one in particular has been moved to the left one. And then y equals 5 is just a horizontal line. So graph these three here.
The square root is just like that one over one for each side.
Yes. Yeah. Also, did I just call you Troy? Okay, second. All right. Here is what these three should look like. Let's see. Put these here where we can see all three of them.
My brother left it at home. Probably have one at home. I don't know. I looked at it today. I thought it looked like a regular one. Too wide.
Oh yeah, it's like square too. I can't stand things that take different chargers. You lose the charger. You might as well just throw it away.
My brother, he still used to, notes. I said, yeah, just come to Charleston and get it.
iPad for Christmas, so it's got like the newer ones have a different charger. Like Hunter's will plug into the phone charger, but his will not. And he's lost his charger. And so right now I don't even know where this charger came from, but we found one that'll fit it, and the cord is like that long. So I've got it like laying up against the wall, plugged into the outlet. We got to get us a new charger for that one. It's somewhere, but Henry's so great at losing things. Okay, all right. So you should have these three, and what we're going to do is we need for this 2x plus 4. We only want to use it for x equals negative 2. So I'm going to go over here on my 2x plus 4 graph. And at negative 2, I'm going to draw myself like a dotted vertical line here at negative 2. You actually don't have to draw it if you don't want to. But what we're going to do is that is our cutoff. We only want to use the part that is less than negative 2. So we're going to take our scissors. We are going to cut on that vertical line right there so that we just have that piece of the graph where x is less than or equal to negative 2. This part over here, the other part of the graph, you can just crumble it up. We'll throw it away in a little bit.
Can we throw that in?
Let's not. All right. Okay, so that is part of our graph. Then you are going to take the absolute value graph. We want to use from negative 2 to positive 3. So we're going to go over here on the absolute value graph, and we're going to do like we did for the other. We're going to put us a dotted line at negative 2. And then I'm going to put myself another dotted line at positive 3. Like that. Those are my lines where I'm going to cut my graph. And for this one, I want to keep that middle part of the graph. So I'm crumbling up the top and the bottom part and keeping that middle section. And then I'm going to line it up next to my other piece of the graph. And then our last part is for our y equals 5, and we're using that for anything greater than 3. So we're going to take and cut that graph with that vertical line at 3. And we are going to use that part on the right-hand side. So we should have a graph that looks like this. Now, if we had cut everything perfectly, it should line up perfectly. I've got a little bit of a gap where mine's not cut quite straight enough, but okay. So a piecewise graph just takes a piece of one function, a piece of the next function, a piece of that third function, and it puts all of those together. Now, there is one thing that we have not done that we must do, and that is we've got to figure out what to do or what to use at those endpoints. So, you can see for 2x plus 4, I've got x is less than or equal to negative 2. So when we have an or equal to, for this first part of the graph, wherever it ends, which is right here, we're going to put, it's not perfect graph there, we're going to put a closed circle, so a colored in circle. It makes it a little hard to write because we're on the like crack of, for the one on the left hand side. So right here, in fact, I think I can, let me do this, it'll be easier. Up here, you guys can't do this, but I can do this. If I click annotate, I can draw it up here, so I'm not trying to draw. So right here, maybe if it will draw for me. Okay. Maybe that's not what I want. What do I want? Why is it not? I could use the circle. And color it in. Why is it not just letting me draw? Oh, there we go. It doesn't like to draw. Okay. Come on. Maybe I'm better off just using just drawing here. So right here at the end of this graph, you would have a closed circle. That should be closed in. My red circle's kind of open, so let's see. No, that's not helpful. Let me just get rid of my... Maybe if I zoom, I bet that'll help. Oh yeah, there we go. So right here, that graph, which my graph is a little bit crooked. This reason it looks a little funny. We're ending with a closed circle right there. We're doing that because on our piecewise function, it said or equal to for that -2. For the middle graph, we've got less than signs for our limits here. They are not or equal to. So for that, we are going to use open circles. So we're going to draw a circle right here that's not colored in. And on this end right here, we're going to draw a circle that's not colored in. And then for the last section, we've got an or equal to sign with that 3. So up here where this one ends, we would have a colored in circle there. Now you can see on this particular graph, our graphs don't meet up. We've kind of got like a jump in the graph, which happens a lot of times with piecewise functions. Sometimes you will have graphs that do meet up, which we'll see here in a second, where you've got like an open circle for one, but then a closed circle that fills that in, so it may look continuous there. Okay, questions? All right, so whenever you're doing piecewise functions, kind of think about like these vertical columns that you're looking at. So whenever you see this x is less than or equal to -2, you're looking at that vertical section from where x is less than or equal to -2, and then you're going to have that graph in that section. So let's do one from scratch without using the sticky notes for this, because we won't have those. I like to actually like cut them apart and piece them together so you guys are seeing what's happening. So you can do the same thing though if you were just graphing. So you've got -2, which is going to be just a horizontal line at -2. And what I'm going to do, because I can easily erase, is I'm going to graph this whole thing right now, and I'm going to erase. You're welcome to do that if you would like, but you also can just draw the pieces that you need. But right here at, I'm going to draw these vertical dotted lines. You do not have to draw them. They're not actually part of the graph. So, 5. So I'm only supposed to use this right here whenever x is less than -5. So at -5, I've drawn myself a vertical line, and I'm going to stop this graph right there at -5. So when it hits -5, I'm going to put an open circle. I'm choosing to use that open circle because over here it was a less than sign and not a less than or equal to. Then for my middle section, I've got an absolute value graph. It has been moved to the left 3. So that will look like this, 1, 2, 3. And then just a slope of 1. On each side. Right now, I am graphing the whole thing. But I am only supposed to use the part between -5 and 1. So that means this section over here is going to be gone. and this section over here is going to be gone. And you guys can see how you can do this without actually drawing and erasing, but if you need to, you can. And this one, I need at -5, which is right here, I need a closed circle. So I need a circle that's colored in. But over here at +1, I don't have an or equal to sign, so I'm going to use an open circle for that. Questions so far? All right, for the next part, I've got 7 for x equals 1. So for this, I'm going to just, what this is going to be, because it's just at x equals 1, it's at that single place where x equals 1. And so it's going to look like this. It's just going to be a dot. 7 itself is a horizontal line, but if we're only using it at x equals 1, it's just a single point on that line. And then for -3x minus 3, if I graph it, it has a y-intercept at -3. I'm going to go up 3 to the right 1, like this. But I'm only, like the whole line looks like this. But I only want to use the part that falls over here where x is greater than 1. So I'm going to erase until I get to that line right there. What type of circle should I use for that? An open circle or closed? Open. Good. And so this would be my graph of my piecewise function here. You will not have to graph these by hand on the test tomorrow. What you will see is either a question that gives you the piecewise function and you have 4 choices for the graphs that match it, or you may see a graph and then choices for your function. Okay, questions? All right, here's the question. All right, try this last one on your own. We are not going to do the stuff that comes after this because we just don't have time since I've been out. So try this last one on your own. If you are having trouble knowing what points to graph for negative x, or square root of -x plus 3, you can always plug in some numbers. So like if you plug in 0, square root of -0 plus 3 would give you 3. So. Okay, so here is what your graph should look like. You don't have to have those vertical lines that I have there. I just put those there to help us visualize each piece that we're looking at. And it's a little hard to see. This is a open circle right here. This one's also an open circle. And what happened on this graph is that right here at 2, you ended up at the same place on that graph. However, you don't have an or equal sign with either one of your 2's, so you just end up with like an open circle on that graph. So you've got a hole in the graph right there for that. If one of these was or equal to, then you would draw the closed circle, because it would be like an open circle, but it gets filled in by that closed circle. All right, questions? Now, we do not have time to do this because I want you to have time to look at the assignment for this and to ask questions if you have any about the review. I just want to very briefly tell you about an application of this, because it seems like nothing that we're doing right now seems very applicable about it. If we had more time, I would go through these problems right here. So in the U.S. and in lots of countries, we have graduated income tax. So this was from 2014. It's old, but so the numbers, I'm sure, have changed significantly, particularly over here on how much money you make. So so these are your tax brackets. This is if was in 2014 if you were filing single. So like I'm pretty sure all of you guys would be filing your taxes single. You can also file married or head of household, or there's some different options there. But if you were just a single person income, if you made between $0 and $9,075, they charge you 10% of your whatever you make. So if you make $8,000, you have to pay $800 in federal taxes. It's 10%. All right. Now this is just federal taxes, because I know a lot of you probably have jobs and you go and do all of your work, and then you're supposed to be getting paid like $12 an hour, and you get your check, and it is not as much as it's supposed to be, right? Because this is just federal taxes, so they take out federal taxes, state taxes, Medicare, or not Medicare, Social Security. There's a Medicaid tax. Is that in Social Security? I can't remember. I have to go back.
All I got taxed for was Social Security.
Might just be Social Security on that. But they take out a bunch of different stuff, right? So this is federal income tax only. There's different brackets for this. There's also all kinds of things you can write off. And this is like the most straightforward. So like if you make between 0 and 9,000, your taxes are really simple. They just take how much you made and multiply it by 10%, and that's how much you got to pay them. And then you have that, they estimate it at the beginning of the year, and then they'll take it out of your check. And if they take too much out of your check, file your taxes, you'll get a refund. If they did not take enough out of your check, file your taxes, you got to pay them more money. So what this becomes piecewise is if you go beyond that first tax bracket. So most of you guys are probably still in the first tax bracket right now. This is probably old. I don't know how high it goes up now. But you probably do not make more than $9,000 a year on your taxes. And this is probably a little bit higher now. You actually might make more than that, but I bet this number's gone up since wages have gone up. So you guys have a really simple tax return. But as you get older and you hopefully make a little more money, you end up in these higher tax brackets. So it becomes a piecewise function, because they're going to tax your money differently at each level. And the way it works too, it's kind of complicated, because like let's say you make $60,000, they do not tax 25% of your $60,000. They tax 10% of the first $9,075. Then they tax 15% of the part of your money that falls between $36,900, and then they tax 25% on everything over $36,000. That keeps it from being like, because if not, then if you went up to the next tax bracket, you'd actually make less money. But it doesn't work it does not work like that, because it's it's going to be graduated there. So you will sometimes hear that, like people say, like if they got a raise at work but they actually made less money because of taxes. If that is the case, it is not because of the tax brackets. It is probably because they are no longer eligible for like write-offs that they used to have. Because if you make over a certain amount of money, you can't claim certain things, and so it's possible, but it's not because of the brackets. So anyway, this is all piecewise function stuff. It takes a while to set up and understand completely. It is a very good application that I would love to spend time with you guys going over, but we are way behind already, so we're not going to be able to do that.